There's a river in North America that shouldn't exist. Well, at least according to scientists. Most normal rivers in the world join downstream, flow downhill, and finally deliver their waters to an ocean or a lake. But the Ikimemish River in Canada doesn't like to follow the rules and flows in both directions. Its name even means water that flows both ways, in the local dialect, Cree. The Ikimemish is just around 37 miles long, but it used to be an important part of the fur traders' route from Hudson Bay to Lake Winnipeg. It runs between the Hayes River and the Nelson River. Its waters are rather shallow and dark as it flows through peat bogs. Things get interesting when you reach the beaver ponds. People who ventured there say the Ikimemish flows toward both the Hayes and the Nelson Rivers, starting from the central beaver pond. It's hard to tell where exactly the water divides as the river goes through a nearly flat, swampy country, and its current is barely noticeable. The next river on our list is the Cassiquiare in South America, and it's like a hydrologic equivalent of a wormhole between two galaxies. It's the only natural canal on Earth that links two great rivers, the Upper Orinoco, which eventually flows into the Atlantic Ocean, and the Rio Negro, the largest left bank tributary of the Amazon River. This rare sort of division is called a bifurcation, and it happens when a single river splits and sends its water into two different places. The Orinoco actually loses parts of its water to the Cassiquiare. From there, the water slowly flows down toward the Rio Negro. During the rainy months, there is more flooding and stronger currents, so a larger amount of water gets diverted. For many local communities, the Cassiquiare is more than just a river. It's sacred. They see it as a path that the ancestral spirits made to bring the great rivers together. Other stories say powerful deities shaped the land to create this special waterway. The Wayambo River in Suriname can flow either east or west depending on its mood. Just kidding. You gotta blame rainfall and human activity for this unusual behavior. People put locks on the river to divert it. One lock, for example, is there to help the rice farmers get enough water. There are at least 3 bifurcation points in the river. It's tricky to control the Wayambo and to predict where the pollutants will spread along the river. It's close to gold mining and oil production sites, so it's a real problem. If you've ever wanted to drink water from 2 oceans at once, North Two Ocean Creek in Wyoming is the place to go. It begins high up in the Teton Range and later splits into 2 branches. The Pacific Creek joins the larger Snake River, which merges with the Columbia River, and finally reaches the Pacific Ocean. The Atlantic Creek heads east and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the 2 creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers who were looking for the Northwest Passage between the 2 oceans never knew they could have used the creek. They would just need really tiny boats. Some scientists believe that cutthroat trout knew about this route long before people. They managed to migrate from the Snake River to Yellowstone River, most likely using this creek. The next star on our list could take over the mighty Mississippi. About 12,000 years ago, the Mississippi started drifting toward the basin of the Red River. The Mississippi stuck to its original path, and the water from the old Red River route became what we now call the Atchafalaya River. It used to be jammed up with logs for about 30 miles and wasn't fit for navigation. By the middle of the 19th century, European settlers cleared the logjam. But the flow of water changed so much that it could mess with the lower Mississippi River. So, people built special structures at the bifurcation to control the way water flowed between the rivers. At times, up to half the water from the Mississippi can get pulled down the Atchafalaya. You can see this massive amount of water even in satellite photos. Digital elevation maps and computer models also show exactly how the rivers split. If those control systems weren't there, the Atchafalaya would probably take over and steal most of the Mississippi's water. New Orleans could lose its main source of fresh water, and shipping along the Mississippi would take a big hit. The Arroyo Partido, meaning parted stream in Spanish, in southern Argentina, also carries its waters to two oceans at once. It starts high up in the Andes Mountains and cuts through a steep forest covered in trees. When it comes out of the canyon, it enters a wider area where a big, rocky outcrop sits right in the middle of the stream and splits it in two. One side of the stream, the left, turns south and eventually reaches the Atlantic Ocean. The other side turns north and flows into the Pacific Ocean. It's pretty unique because the bifurcation doesn't happen in a flat lowland, but in a mountain saddle. It's kind of like a dip between two mountain peaks. You won't find much about Arroyo Partido on most maps though. That's partly because the area wasn't well mapped until the late 1800s, and partly because the stream is small and surrounded by lots of bigger rivers and lakes that usually get all the attention. Also, there are no public water flow models available for this stream yet. Still, people have confirmed the split using aerial images and photos taken by hikers and travelers. A digital elevation model also shows that if you poured water right in the area where it's supposed to split, it would naturally flow both ways. Divide Creek is located on the border between British Columbia and Alberta in Canada. This stream flows down a mountain and reaches a saddle-shaped area called Kicking Horse Pass, where it splits in two. It happens because of Summit Lake, which sits just west of the Continental Divide. A long time ago, Summit Lake was much bigger and probably stretched across the entire pass, possibly causing the stream to split back then too. But over time, the lake got smaller and now only exists on the west side. It left behind a swampy wetland right at the highest point of the pass. Like Arroyo Partido, Divide Creek didn't show up on many old maps. It's small and the area is covered with thick forest, so even aerial photos don't clearly show the stream splitting. The best proof we have today comes from Yoho National Park, where a marker explains the bifurcation. It's placed along a hiking trail, and if you're up for an adventure, you can take a short side path that leads right to the spot where Divide Creek divides. Now, how about a lake for a change? Wollaston Lake is tucked away in the far northwest corner of Saskatchewan, Canada. The coolest part about it is that it also bifurcates. Near its northern end, about 90% flows into the Cochrane River and heads northeast, and around 10% flows into the Fond du Lac River and goes northwest. Where the water ends up, either toward the Arctic Ocean or the Hudson Bay, depends on which side of a long peninsula it's on. Maps and models show that there might still be some water flowing between the two sides of the peninsula, so technically it's not a perfect bifurcation, but it's still one of the most fascinating natural features around. The peninsula itself is slowly eroding, and eventually it might disappear. But geologists say that because of the Y-shaped layout of the lake, the water will keep splitting into both river systems no matter what. Even long before European explorers came around, the local people already knew how special Wollaston Lake was. They called it Lake Manitou, which means spirit. They believed the lake had supernatural powers because of its rare position at the top of two major watersheds.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. Now, of course you know that the Amazon River is famous for its piranhas, bull sharks, and other creatures you don't want to meet. But there are even more dangerous rivers in the world. The deepest of them, the Congo, goes so far down in some sections that even light can't reach there. It's the only major river that crosses the equator twice and carries enough water to fill more than 13 Olympic-sized swimming pools into the Atlantic Ocean every second. Wow! Even the most experienced boaters have trouble passing through all of the river's strong currents, rapids in its upper part, and waterfalls and gorges in the lower section. The Congo currents are so fast and powerful that they even divide animals like mountains and oceans do. There are new species of fish evolving separately on the two banks as they can't reach the other side and breed with each other. One of the most dangerous types of fish living here is the Goliath tigerfish. These monsters, that grow up to 5 feet and travel at the speed of 25 miles per hour, are relatives of piranhas. Their mouths are full of vicious, razor-sharp teeth. Their females lay hundreds of thousands of eggs, and the offspring are predators from birth. You have a good reason to fear the Goliath tigerfish, as they're the only freshwater fish in Africa that have attacked crocodiles and even humans. Okay, not swimming there. There are dense jungles and more hungry wildlife, including snakes and some aggressive hippos, all along the river. Still, it's used as a water highway in Central Africa, so barges traveling on it for weeks are often crowded with up to 2,000 people and capsize every now and then. And if you believe the local folklore, there's one more thing to be afraid of: the one who stops the flow of the rivers, a dinosaur-like beast that is said to live in the Congo River basin. There have been over 100 sightings over the last century, but no one can provide solid evidence the beast is real. At the turn of the 21st century, there was a series of terrible, mysterious stories on the Kali River in Asia. Something described as a mud-colored water pig would drag swimmers underwater in front of terrified eyewitnesses. British biologist Jeremy Wade stepped up to crack the case. He noticed that all the scary incidents were happening in one specific spot, stretching about 4 miles. Villagers told him this creature was growing big and bad from all the food it got. Wade examined the water with a depth sounder, and thought it could have been a whirlpool. Then the monster dragged a domestic water buffalo into the water. The buffaloes are big and heavy, so the creature that attacked it would have to be super strong. Saltwater crocodiles don't go so far inland, and the most common local species of crocodiles don't live in cold waters. There were no bull sharks in the area either. Finally, Wade spotted several goonch catfish underwater. Some of them were human-sized. They couldn't capture these monsters with a regular fishing rod, but a special ceremonial construction did the job. The largest fish was 6 feet 7 inches long and 3 times the weight of an average gaunch. It was large enough to take down a human or a large animal, but Wade mentioned there could be even bigger ones living in the Kali River. The Orinoco River in South America is dangerous to navigate because of some crazy curves and strong underwater currents. It's easy to get lost here, even if you have your GPS on. There are sudden waterfalls all along, and you must be prepared to handle those to survive. The river is the only home to a rare Orinoco crocodile and has some pretty scary-looking vampire fish swimming around. This payara fish has sharp, spiky daggers that line their gums and 2 elongated fangs that rise from their lower jaws. Could probably use an orthodontist and some braces, you think? It's a ferocious hunter constantly looking for the next victim, which is going to be a medium or large-sized fish. If a human catches a payara, it will defend itself, leaving cuts, nips, and bites, but there are no known cases of this cutie taking a human life. Well, that's good. The Yellow River in China received its name after its color, but it wasn't always this yellow. It was first formed at least 30 million years ago and shifted its course over 30 times over the centuries. Yellow sediments moving downstream from a plateau in the distance transformed it from clear to muddy. This fine-grained substance piled up at the bottom of the river and formed natural dams. The huge amounts of water that the river carries need to find their way to the sea, and that's when major floods happened, taking several million lives in various epochs. The locals tried to solve the problem by building higher and higher levees, but it only made things worse. Water coming out of the river would now have nowhere to back up, as the riverbed was higher than the surrounding land. This even shifted the river's mouth. Now there are massive dams and dikes all along the river to try to contain it. The Parana River is the second longest in Latin America and has many tributaries. They flow in from the highlands near the Andes, and there's a huge drainage in the wet season. This makes the river a perfect home for, guess what, piranhas. There are 30 to 60 species of these scary fish in the Parana waters. In late 2013, they attacked bathers cooling off by the water on a hot day. People started running out of the river as they felt something was biting them in the water. Luckily, no one lost their lives in the accident, but it's still considered one of the most audacious piranha attacks ever recorded. Biologists later determined that the type of piranhas, called palomates, was to blame for this, and humans had probably disturbed their breeding grounds. Well, the piranha also has a strong current that is tricky for boats and swimmers to overcome. Plus, it often floods, which can be dangerous for people living in the surrounding areas. The longest river in the world, the Nile, flows through 11 countries all the way into the Mediterranean Sea. Expeditions have spent centuries looking for its source, and no one still knows for sure where this mighty river begins. Adding to the mystery, the Nile takes an unexpected turn right in the middle of the Sahara. Scientists have figured out the reason is a massive underground rock formation from millions of years ago. The Nile has served as the most important water highway for civilizations through centuries, but it has some pretty dangerous inhabitants, like crocodiles that grow to be 20 feet long, which is slightly more than the height of an average giraffe. These bad guys can reach a speed of 30 miles per hour on land and take the lives of a couple hundred people every year. Hippopotamuses that also live here sometimes go after boats, and venomous snakes like the black mamba and the Egyptian cobra add to the mix. One of the most dangerous creatures on the Nile is the mosquito, as they carry around all sorts of diseases that affect hundreds of thousands of people. The Brahmaputra River in Asia carries waters from the mighty Himalayas. When the snows in the mountains melt, the river floods massively, causing landslides, displacing millions of people, and taking the lives of hundreds of animals in the nearby national parks. Such floods are also common during the monsoon season in India, from June to October, with heavy rains. The course of the Brahmaputra River is changed incredibly over the past 2.5 centuries. Erosion is another danger it's hiding. The banks of the river are mostly made of weak cohesive sand and silt, and even though the erosion rate has gone down, it is still the reason a lot of people lose their land and get displaced. The Brahmaputra is one of the few rivers in the world that has a tidal bore. That's a strong tidal wave that pushes up the river against the current where a river empties into an ocean or sea. And there you have it.
In 1969, two brothers went fishing on the Altamaha River in the Clark's Bluff area. They cast their fishing rods, ready to wait for some fish to bite their bait. But at that moment, they saw something strange. At first, they thought it was a sturgeon. But then, they saw that the length of this sturgeon was about 13 feet, almost as tall as 2 basketball players. Of course, such a size didn't frighten the brothers because some species of sturgeon can reach a length of 24 feet, which is about 3.5 basketball players. Something else surprised them. The face of this creature resembled that of an alligator. The tail was horizontal. It had a triangular crest along its upper body and sharp metal-colored teeth protruding from its mouth. A creature that looked like a dinosaur was quite an unusual phenomenon for the time when Steven Spielberg was an aspiring young director and didn't even think about creating Jurassic Park. So, on that day in 1969, two brothers saw something elusive, like Bigfoot or the Loch Ness Monster. They saw a creature that had been the subject of stories for centuries, a creature that is being searched for even today. They met Altamaha. This is a famous and narrow circles monster that lives near the mouth of the Altamaha River in southeastern Georgia. People from the Lower Muskogee Creek tribe talked about it long before the British colonization. In ancient times, there were legends about a snake-like lizard that bellowed and hissed. So this monster has already been elusive for several centuries. But do you know what distinguishes Altamaha from Nessie, Chupacabra, and others? Yes, there are no bad quality photos or videos of Altamaha, but there's a huge amount of evidence from different periods. For the locals, Altamaha is so real that one artist created a detailed statue of this river beast. Of course, it's not accurate because it's based on eyewitness accounts. But you'll probably agree that it would be scary to see such a cute animal in the middle of the river while fishing. Almost all the stories are about a creature without hind limbs, but with front flippers, which swims like a dolphin, has a crocodile face, big eyes, and large, sharp teeth. It's gray or green with a whitish-yellow belly and a bony crest on its crown. And most interestingly, people have seen this creature in different sizes. Of course, when you see an unknown dinosaur-like thing, you can exaggerate its size or estimate it incorrectly, which explains the difference in statements. But there's also a probability that Georgia is home to a big family of Altamaha. One of the first people to see this creature and report it to a local newspaper was Captain Delano. On his schooner Eagle, he was sailing near St. Simon's Island, below the mouth of the Altamaha River, when he saw a creature about 70 feet long, which is almost twice the size of a school bus. Its body was like a barrel, and its head was like that of an alligator. It's possible that the captain greatly exaggerated the size of the monster because of the excitement, but several other people who were with him in the boat confirmed his words. From that moment on, reports of the river monster began to appear more often. Someone saw it flashing along the river. Others saw how it behaved defensively towards people. And some people reported that Altamaha was just basking in the sun. Just imagine its displeasure. Not only fishers met Altamaha. In the 20s of the last century, lumberjacks were crossing the river and saw a huge snake-like monster. In 1935, a group of hunters saw a creature they called a giant snake. In the 1940s, Boy Scouts encountered a similar creature. And in the 1950s, 2 employees from Reedsville State Prison saw it. For so many years, people have been meeting it, and no one has ever managed to catch the monster. Perhaps it's smarter than it looks and always very careful. Maybe people are afraid to touch it. Perhaps they consider it a national treasure and protect it. But one day, there was a case when Altamahaha almost fell into a trap. In the summer of 1980, 2 men saw a monster wallowing on a muddy shore. It seemed like it was stuck and trying to get out. The witnesses said that the rough, dark-skinned creature had finally left the shore, dived into the water, and disappeared. Later that year, another man said he had seen something similar. A snake-like large creature with 2 brown humps protruding from the water. It dived into the water and churned the surface, like a boat while moving. Other witnesses catching crabs described Altamahaha as the largest eel in the world. Okay, stop! Many saw it in the last century, but what about more recent news? Is the monster still alive? Oh yeah. In 2002, a man was pulling a boat upriver near the town of Brunswick when he noticed something large, 20 feet long and about 6.5 feet wide, breaking out of the water. In 2010, a photographer caught something strange on camera floating along a canal in the city of Darien. And these cases are just the ones we know about. Surely, many people have seen this thing but haven't talked about it in newspapers or on the internet. If you don't believe these stories, you can go to Darien, get on a boat, and ride along the river to see this monster with your own eyes. Yes, according to reports, this creature always tries to avoid people. It's very cautious, but all the same, you should not get too close to this water lizard twice the size of a school bus. Go to the Museum of Darien to take a photo of the Altamahaha statue. There are also souvenirs with the image of this monster. But let's assume that you or someone else managed not only to take a clear photo of the Altamahaha, but also catch it. What is the next course of action? What are you going to tell the world, and how will the world react to it? What will happen to the poor animal, surrounded by millions of flashes from reporters' cameras? Will people make a show out of it or send it to a lab? Fortunately, in 2001, scientists already developed an action plan. This plan was drawn up by Scotland's nature agency, NatureScot, since they had concerns about the Loch Ness Monster. At some point, it became too popular and too many people tried to catch it, so the agency became concerned about saving the life of the famous creature. They showed the Nessie contingency plan that can also be used for any unknown animal that lives in water or on land. According to the plan, if the ancient lizard is captured, scientists should take its DNA sample and just release it back into the wild. Fair enough. The animal will receive the same legal protection as other local wildlife in Scotland. All attempts to catch it will be prohibited. But let's imagine that this is exactly what happens. Scientists receive a DNA sample of the Altamahaha, the Loch Ness Monster, or other similar creatures. What could those be? Some ancient descendants of dinosaurs? For example, the plesiosaur looks like a distant relative of these monsters. It's huge and has a long neck and a toothy mouth. What if it managed to survive and reach the Altamaha River? Or it may be a completely new, unknown species that lives in deep freshwater. Some people who saw Altamahaha said that it had produced a hissing sound. What if it's some kind of ancient python or anaconda that moved from land to water and grew fins? In any case, it should not be ruled out that it may be some kind of eel or sturgeon. One day, someone saw it, was impressed, and told other people about it with great exaggeration. Everyone believed it and started spreading the story. What do you think?
All right, listen up. One of the greatest threats to humanity comes from large corporations planning to extract minerals from the ocean floor. The point of no return could be reached this year. The ocean could stop breathing in some places. Yet some people see no problem in this. Or perhaps they simply refuse to see it. And here's the kind of cheerful news you might hear about it. Many terrestrial resources are depleting, and the demand from major corporations for valuable metals and minerals is growing. The cost of technology is rising. Consumers can't afford to buy laptops and smartphones, and artificial intelligence might slow down the pace of development. But there is a solution: seabed mining. Ooh! The ocean contains so many valuable resources and minerals that there will be enough for everyone. Prices won't rise, progress will accelerate, everyone will be happy, and blah blah blah. What beautiful words! But there are also many risks. Companies want to extract metals from the seafloor and say they will take all the necessary measures to minimize harm to the environment. But they don't know the consequences. Nobody knows, since this seabed mining is an experimental technology. But unfortunately, this may be incredibly destructive. Yes, the shortage of natural resources is a real problem, but we must not solve it by exploiting the ocean. So, what can we do? There will be some suggestions at the end of this video, but for now, let's focus on the problem. So, have you ever heard of dark oxygen? Scientists recently discovered oxygen 2.5 miles beneath the surface of the Pacific Ocean that is produced without light and without photosynthesis. Do you understand what this means? The oxygen we breathe on land is generated by plants, trees, and sea algae through photosynthesis. But it turns out there's another way. In the deepest, darkest parts of the ocean lie strange, potato-shaped metallic lumps called polymetallic nodules. And these unique formations produce oxygen. They likely existed on Earth long before photosynthesis appeared, billions of years ago, which means studying this phenomenon could reveal countless secrets about our planet. Now for the bad news. These nodules contain a large amount of manganese, nickel, cobalt, and copper, which makes them a valuable resource for advanced battery manufacturing. Extracting this material could destroy the oldest chemical processes on Earth and interfere with critical scientific research. Moreover, we still don't know how significant dark oxygen is to the global ecosystem, or what consequences its extraction might cause. At the very least, it could threaten the extinction of all species that rely on dark oxygen to breathe. Now, this is far from the only problem associated with seabed mining. Imagine a massive tanker arriving at a specific location in the ocean, lowering a giant drill or a massive suction tube, similar to a vacuum cleaner, to the seafloor. Workers turn on loud motors. The drill crushes the ocean floor, and the suction tube pulls up sand. The entire process produces a deafening noise that can disrupt echolocation, for example. A blue whale sends a signal to a friend and suddenly hears the deafening roar of a drill. Now imagine the noise caused by dozens of such tankers, hundreds, thousands. How many fish species will be frightened and remain in constant stress? The consequences of this noise pollution are difficult to predict. In addition, seabed mining can pollute the ocean floor with sedimentary deposits. This is an even more serious threat to ocean life. Here's why. A huge pump sucks up massive amounts of sand. On board the ship, the sand is processed. People extract valuable materials, metals, and other useful substances, while all the leftover sand is dumped back into the ocean. Tons of processed sand slowly settle back to the seafloor, falling on the heads of marine creatures. It's like a dust storm or a cloud of dust that stretches for miles. While the residual material is being dumped, giant pumps suck in new tons of sand. Then, after processing, it falls back down. And the cycle continues over and over. In this way, seabed mining can harm not only dark oxygen, but also the regular one that fish breathe through their gills. As they filter water through their gills, they'll also filter sand particles. Unlike humans, they don't have respiratory masks. This is yet another serious blow to the ocean's biodiversity. And don't forget that along with the sand, the pumps may also draw in octopuses, corals, crabs, and other crawling marine creatures. All of them are part of a fragile ecological chain. For example, sea pigs are deep-sea creatures with transparent bodies resembling snails and jellyfish. They're very fragile and can only survive under high pressure. If brought to the surface, they disintegrate. They don't swim but walk along the seafloor and serve a very important role. As scavengers, these animals clean the ocean floor of debris. They are essentially the ocean's janitors. Crabs even use them for transportation and protection from predators. Since sea pigs are toxic, Enemies don't approach them, so crabs travel safely on their backs. What will happen if seabed mining pushes these amazing creatures to the brink of extinction? Who will clean the ocean floor of debris and decaying materials? No one knows what consequences the disappearance of these creatures might have. What about corals? Some live from 400 to 4,500 years. Some marine sponges live up to 11,000 years and are among the oldest known living organisms. And yet, we risk destroying this ancient world for the sake of our technology. Imagine a massive tube appearing above your city right now, sucking up everything – houses, roads, streets, villages, people – and then dropping everything back except for metal objects. The streets would turn into a chaotic mess of dust and broken concrete. The same will happen to the seafloor, which is home to countless marine inhabitants. Deep seabed mining could destroy rare species of animals, even ones we don't yet know exist. The ocean floor in some areas has been studied less than the surface of the moon. We have no idea how we might harm nature with such operations. We have rarely mined minerals under such conditions. The technology is highly experimental, and we need all of this for making batteries, powering modern technology, and supporting artificial intelligence. Perhaps it's worth stopping and finding alternative sources. Perhaps we should not destroy our own home. Now, don't worry, we won't end this video on such a grim note. Of course there's a solution. To address the shortage of necessary metals and minerals, we don't need to destroy the ocean. Think back to the last time you replaced your phone or bought a new microwave. What did you do with the old devices? Did you throw them away? Sell them? Give them to friends? Every day, people discard tons of old electronics. Almost every old TV or computer contains small amounts of copper, nickel, and other elements. So if we collect this unwanted junk, extract the necessary metals and minerals, and reuse them, we can reduce the need for seabed mining. Companies spend millions of dollars building tankers, drilling rigs, and paying engineers. Why wouldn't they spend that money on organizing the collection of valuable metals and recycling old equipment? Every person could mine useful minerals right at home. And there's another solution. In 2026, many technology giants are going to switch to new sodium-ion batteries, which could eliminate the need for deep-sea mining. The thing is, today, battery production relies heavily on lithium. This element is difficult to extract, and working with it produces many chemical byproducts. One of the places where it's mined is the ocean. But the new batteries are much cheaper, essentially composed of the same element as table salt in your kitchen. They last longer and are far safer to use. Sodium-ion batteries are among the most promising technologies in the field of environmentally friendly materials today. Moreover, large corporations can use artificial intelligence to develop effective plans for extracting and replenishing necessary elements. So, don't despair. We are capable of saving the ocean and preserving the lives of millions of its inhabitants, if we choose to do so.
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine. See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer, but be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people. and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown of thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate. When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature, and this is another equally important reason why we should stay away from them.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. this sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet.
They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Deep under the Indian Ocean, there's a giant patch where gravity doesn't work like on the rest of the planet. I mean, the gravitational pull works constantly, but Earth is not a regular sphere. Its surface is not smooth. It's covered with lumps and bumps like a potato, because our planet is not the same everywhere inside. Some parts are denser than others. Let's say you could pour water across Earth's surface. The shape this water would make is called a geoid, and it's like that because of the differences in materials inside the planet. That's why gravity isn't the same everywhere. And down there in the dark depths of the Indian Ocean, it's weaker than usual. That spot is something we consider a giant gravity hole that stretches more than 1 million square miles in size. It's roughly where the ocean floor sinks down in a giant depression. Scientists used ships and satellites to figure out this mystery. They realized the water level near India was lower because of this weak gravity spot. They're still not sure what made gravity become so weak in that area. But 2 Indian researchers realized everyone was trying to understand this, considering what that area looked like in the present. So they decided to go to the past. They used computers to make models of a virtual Earth and figured out that the answer could lie over 620 miles under the surface. That's where a part of an old ocean sank 30 million years ago, causing a hot melted rock to move around. And this mixture might have made gravity weak in that area. It's a really interesting idea, but it's still not the final answer. In 2018, a team of scientists from India went to the Indian Ocean with special machines to listen to the ground rumbling, similar to when you hear thunder. They found out there were hot streams of melted rock coming up from deep inside Earth. Could they be part of the reason why the gravity is weak there? We'll need more information to understand the issue better, maybe even go back further into the past. For instance, about 140 million years back, the land was all connected as a big piece called Gondwana. But then, India started moving away from it. While India was moving, an old ocean floor called the Tethys Sea sank into Earth's insides. These 2 scientists from India kept trying to solve the case, using computers to pretend to be going back in time. They checked how the land moved, as well as the mantle, which is basically a thick layer of hot, solid rock. The duo found out that a long time ago, there were hot, light rocks rising from deep inside Earth. These rocks created a spot where gravity was weak. This spot was like a big dent in the ocean floor. The more these rocks rose, the deeper the dent became. The first of these rising rocks popped out around 20 million years ago to the south of the weird gravity dent. As these rocks moved and went under the land, the dent got bigger and stronger. The 2 scientists think these rocks were pushed up by the sinking old ocean floor, like bubbles. This process disturbed something called the African blob. You gotta see this. Deep inside our planet, there are 2 very big blobs, like giant pieces of rock, as large as continents. One is under Africa, and the other is under the Pacific Ocean. These blobs have roots that start almost halfway, 1,800 miles, toward the center of Earth. And they're probably the place where columns of hot rock rise up from way down below. When these hot rock columns reach the surface, big volcanic eruptions happen. And we're talking about some really massive ones that might have even played a role in erasing dinosaurs from the face of the Earth a long time ago. So, we don't want these giant blobs to be disturbed. Anyway, not all scientists agree with the theory about why gravity doesn't do its job in this particular spot in the Indian Ocean, saying they need more proof to be sure about these rising rocks. The real answer might come from listening to Earth's rumbling. Plus, who knows if this gravity hole will stay there forever or move away. It depends on how Earth's mass will shift around. To see some changes might take a very, very long time, maybe even hundreds of millions of years. That's not the only region where gravity works in mysterious ways. Or at least, that's what it feels like when you see certain things around the world. Like, what if you saw rocks that don't sink, but can float on water for a very long time? They can even travel around for thousands of miles until they finally find a spot where they sink. Scientists figured out how this worked by using special X-rays to check the insides of these rocks. And these unusual rocks turned out to be very light and full of tiny holes. Researchers used wax to cover pieces of these rocks and went with a special X-ray method to look inside the rocks to see how much water and gas was there. The reason these rocks can float is because of something called surface tension, which is like a very thin, the size of a human hair, layer of air on the water's surface. This helps some animals, like lizards and insects, to really walk on water. And these floating rocks are not just cool because they travel, but also because they can actually help scientists find underwater volcano eruptions. They can also carry living things across oceans since they tend to collect some plants and other things rich in nutrients. So it's basically like a free cruise, until you sink down at some random spot. No iceberg needed. Here you have floating rocks. And in Death Valley in California, there's a strange phenomenon where big rocks move across a dry lake bed and leave trails behind them. People wondered how this was possible for 60 years until the case was solved. Some thought there must be strong winds moving these rocks, or maybe even ice. But scientists found these winds aren't really strong enough to move such big boulders. They placed cameras on cliffs near the rocks, even though they were hard to reach. They did this for 3 winters in a row to study the temperature, rain, and wind in the area. Their idea was that ice might lift the rocks and let the wind push them. To test this properly, they put a rock in a container with water and sand and froze it. When they later pushed the container, the rock moved like it was on ice. This experiment helped prove their theory. And what's interesting is that the rocky area in Death Valley is similar to one of Saturn's moons, Titan. So these weird things on our planet may help us understand other phenomena, even in space. The reverse waterfall in England is an example of a spot with weird gravity too. You can find it not far from Hayfield. It has water that looks more like a fountain than a waterfall, considering it goes up toward the sky. But it turns out gravity doesn't have anything to do here. It's just the wind. It's so strong that when the water falls down, it catches it and pushes it back up. But where does this constantly strong wind come from? You can see a similar thing at Hoover Dam in Nevada, US. Try to climb up the dam, 726.4 feet, and pour some water out of a bottle. Not working? Yep, the water won't flow down as it normally would. It will fly up. You'll have the same result if you throw some light object from the same height. You will get it back. And this happens because of the strong airflow too. So these things seem like gravity is messing up with us. But there's always a logical answer behind that. Hopefully, we'll get one for the gravity hole in the Indian Ocean too.